Welcome back to another interesting video from SpeedMath Techniques. In today's video, I will be teaching you to find the inverse of a 3x3 matrix just within a minute. Although it is important to know the conventional computational methods, it is also very important to learn shortcut methods as well. You can save a lot of time in cross-checking the accuracy of your computations using these shortcut methods at competitive exams. Okay, now we look at the invertibility of a matrix. We can find the inverse of a matrix only if it is a square matrix. That is, if the number of rows equal to number of columns. There is another condition to be satisfied for a matrix to be invertible, which I will explain to you later. Before we move on to explaining the computations, if you are new to my channel and if you have not subscribed to my channel, please subscribe to SpeedMath Techniques channel and always remember to click on the bell icon so that you will always be notified of the new interesting video additions. SpeedMath Techniques is available on Facebook at EasyMathsLK. Follow us on Facebook to get interesting updates on SpeedMath Techniques. Okay, now let us get back to learning our shortcut method. We assume that A is a square matrix of the order 3x3. Then the inverse of A is denoted by A to the power minus 1 and is given by the formula 1 over determinant of A matrix into the adjoint of A matrix. So we have two steps in our calculations to find the inverse of A. Step 1 is to find the determinant of A matrix and step 2 is to find the adjoint of A matrix. Right. We are now going to look at these two steps separately. Okay, now let us move on to the first step of our calculation, that is finding the determinant of A. We will take the A matrix, which is a square matrix of the order 3x3, where the elements of the matrix are 1, 2, 3, 2, 2, 4, 1 and 1, 5, 4. Next, we are going to copy the first and the second columns of the matrix, appending them as two more columns to our original matrix. After copying the two columns, we will now end up with a 3-row and 5-column matrix or a 3x5 matrix. Now, if you observe, you can see that there are 3 diagonals within the extended matrix as illustrated. What we do next is multiply the values in each of the diagonals separately and write them at the bottom of each diagonal. That is 1 into 4 into 4, 16, 2 into 1 into 1, 2, 3 into 2 into 5 is equal to 30. Likewise, you have another set of diagonals in the opposite directions. We now repeat the same multiplication for this set of diagonals and write the values at the top end of each diagonal. That is 1 into 3 into 4, that is 12, 5 into 1 into 1, 5, and 4 into 2 into 2 is equal to 16. Now add the values in each set of diagonals separately. That is 16 plus 2 plus 30 is equal to 48 and 12 plus 5 plus 16 is equal to 33. Now it's time to find the determinant of the matrix. What we do here is we deduct the summation of values at the top from the summation of the values in the bottom. That is 48 minus 33. The answer is 15. This is the determinant value. Now let us get on to step 2. Step 2 in our calculation is to find the adjoint of matrix A. To start with, repeat column copying like in the previous slide. By doing so, we will now end up with a 3x5 matrix. Now we copy the first and the second rows of the modified matrix and append these two rows to the end of the original matrix. As a result, we have now ended up with a 5 by 5 matrix. Next, cut off the first row and the first column of our resultant 5 by 5 matrix, so that we end up with a 4 by 4 matrix. Now it's time to build our adjoint of matrix A. Here is how it's done. You cross multiply the column elements as shown. You must remember that we take the difference in each cross multiplication, that is 4 into 4 minus 5 into 1. Here, while multiplying column wise, we will fill up the adjoint matrix on a row wise. 5 into 3 minus 2 into 4, 2 into 1 minus 4 into 3. Then you move on to the next two columns and start filling the second row of the matrix. 1 into 2 minus 4 into 1, 4 into 1 minus 3 into 1, 3 into 2 minus 1 into 1. Next, 2 into 5 minus 1 into 4, 1 into 2 minus 1 into 5, and 1 into 4 minus 2 into 2. Right, when we simplify these numbers, we will now end up with a 3 by 3 matrix, which is the adjoint of matrix A. The elements of the adjoint of matrix A are 11, 7, minus 10, then minus 7, 1, minus 5, 6, minus 3. Okay, now we have computed all the numbers to find the inverse of matrix A. Inverse of matrix A is equal to 1 over determinant of matrix A multiplied by adjoint of matrix A. This is the place that I said that I will explain to you another condition for the invertibility of a matrix. If you see this formula, if the determinant of the matrix is 0, and we cannot define the inverse of matrix A. Now we will substitute the numbers that we computed. Inverse of matrix A is equal to 1 over 15, which is the determinant value of A, multiplied by the adjoint of matrix A, that is 11, 7, minus 10, minus 7, 1, minus 5, and 6, minus 3, and 0. So when you multiply these numbers from the constant 1 over 15, you will get the following A inverse matrix. Hope you enjoyed the video and you will be able to use this method to find the inverse of a 3 by 3 matrix. Thank you very much for joining with Speed Math Techniques.